In this video, we're going to go over some of the questions from your Unit 5 Mid-Unit Formative Assessment. It is one of the most important units in the grade 9 course for math, so it's important that you understand the concepts. If you didn't do so well in the quiz, even if you did well and just guessed, it's important that you go through the notes, through the quiz to make sure you understand the concepts, understand the questions, and to really get what all these different terms mean, because in grade 10, in grade 11, 12, the fundamentals of the course basically deal with your ability to graph things, to understand what a line is, and there's more complex types of graphing as well. So if you can understand the basics here, you're setting yourself up for a good foundation for success in future courses. So let's go through the first question here. First question is, which of the following determines the steepness of a linear relation in y is equal to mx plus b form? As you know, you did an investigation activity where you studied steepness. And you know steepness relates to the m, to the slope, to the m. Now the trick here is that you have to choose a proper m. So we know it's not b, that's the y-intercept. So not b. So we're looking at, is it the magnitude or is it the sign? So if we had an equation like this, y is equal to negative 3x plus 5, we know the steepness is determined by this m value over here. Now what we care about is the actual value itself, the magnitude, that number there. It's not the sign that tells you the steepness. Remember, the sign tells you the direction. Is it rising from left to right or falling from left to right? What determines the steepness is the magnitude of the slope. So the correct answer would have been the magnitude of the slope. So again, that was through the investigation activity. Understand that steepness is determined by the size of that number there. Okay, the magnitude of the slope, not the sign. And let's just check to make sure we are right. That looks good. So we are good, the magnitude of the slope. And just as a little example, if we had y is equal to 3x plus 6 and y is equal to 0.5x plus 6, and I'll put a negative in front here. The steeper one is going to be this 3x here because it has a higher slope than 0.5x. I didn't look at the sign, I looked at the number itself. 3 is larger than that 0.5, so this will have the steeper, a higher steepness. Okay, so let's move on to our next question. So, which of the following determines the y-intercept of a linear relation? When we look at the y-intercept, y is equal to mx plus b. If I had y is equal to 3x plus 6, I can tell the y-intercept is at 6. Meaning that if I were to write it as a coordinate, I would have 0, 6. That is my y-intercept. So that's where my line would first hit the y-axis. So it would be at 0 for x, but 6 for the y-coordinate. So it's the b value that determines the y-intercept. It's both the sign and the number. So here the y-intercept is at plus 6 of 0, 6, whereas if I had something like this, 3x minus 6, the y-intercept would be at somewhere in this quadrant here at the negative 6 area on the y-axis there. So that would be how you determine the y-intercept. So again, it's the b including the sign. And let's check to make sure that we're right. We are, b including the sign. Perfect. All right, now we go on to the next question. Which of the following is true when comparing these two equations here? So we have negative 12x plus 9 and y is equal to 12x minus 9. So y is equal to 12x plus 18 is more steep than y is equal to negative 12x plus 9. Well, steepness refers to the magnitude of the m. These both have the same magnitude, 12 and 12 for m. I know there's a negative there, but that doesn't determine steepness, that determines direction. So this is not true, this statement here. 12x minus 9 falls from left to right. So if you have a positive m, that actually goes up from left to right. And then negative 12x plus 9 rises from left to right. No, this has a negative in the front, so this falls from left to right. So this is not true either. Y is equal to negative 12x plus 9 and y is equal to 12x minus 9 have the same y-intercept? No, because this one has a y-intercept of 0 plus 9. This has 0, negative 9. So they do not have the same y-intercept. So those are already crossed out. Let's take a look if this one's correct. Negative 12x plus 9 and 12x minus 9 have the same steepness. Yes, they have the same magnitude for m, the same number for m. We don't care about that negative when it comes to steepness. So this would be the correct answer over here. That those two equations have the same steepness. Let's double check to make sure we're right. Yep, they have the same steepness. Perfect. Let's just erase this ink and go on to the next question. So here we have, which of the following are examples of direct variation? And so we have the equation represented in different formats. If we look at the first, so if you are looking at an equation, if you have direct variation, let's fix that. If you have direct variation, you are only going to have a multiple of x. So for example, 2x or 5x or 0.5x and nothing else added or taken away from it. So this, for example, this would be partial or indirect because it is a multiple of x, but then there's also that minus 6 part there, so that takes away from it. This one here, yes, this is just a multiple of x. That works perfectly. Now, how can you tell if you have direct variation when you're dealing with a table of values? Well, if your line goes through 0, 0, then you have direct variation. So let's go look at our 0 value at our x here. When x is equal to 0, y is equal to 5. So our line does not go through 0, 0. When x is 0, y is 5. So we have 0, 5. So this is not direct variation. This one here is not direct variation. Like I said, if your line goes through 0, 0, then you're dealing with direct variation. If you look here, this line does cross that 0, 0 point, the origin there. So yes, this would be an example of direct variation. And then let's take, so far we have those two selected, and let's take a look at the last one there. We have another graph. This other graph here, you'll notice that it doesn't go through 0, 0. When it's at 0, here, our y value is 1. So because this does not go through 0, 0, this is not direct variation. So our direct variation answers were this one, and so that equation, and this graph. So there should be two that are selected. Let's go and take a look to make sure we are right with that. So we had, yep, that one, and then that graph there, so two selected. Perfect. So next, let's go to this question here. Which of the following is true regarding this graph here? So the x-intercept is 0, negative 2. X-intercept is where the line hits the x-axis. This is the x-axis. This is the y-axis over here, the vertical one. Vertical up, down, x-axis, horizontal, left, right. So x-intercept is 0, 2. First of all, x-intercept, you'll have an x value that's not 0. So if we look at our x-intercept, this is where the line hits the x-axis. That coordinate is negative 2, because you're 2 units on your x-axis to the left, and then 0 for the y. You haven't moved up or down. So the x-intercept would actually be negative 2, 0, so this is incorrect. The x-intercept is 0, 2? No. As we said, it's negative 2, 0. The y-intercept, let's take a look. Here's our y-intercept. Y-intercept means when your x is 0, what is your y? Where does it hit the y-axis? Yes, it happens to be 0, 4. 0, 4. And so this one is correct. The slope is positive. Well, let's take a look. This rises from left to right. Left to right. Because it rises from left to right, it means that the slope is indeed positive. So those are two correct answers there. The slope is positive. So we'll check to make sure that we're right there. Yep, intercept 0, 4, slope is positive. Good. So which of the following are true about this equation here? So let's go and try this out. So the y-intercept is 0, 10. So y-intercept means when x is 0, what is your y value? So let's go plug that in. I'm doing sloppy work here just to show you the concept. You should be doing proper work. So I'm going to put x is 0 minus 5y is equal to 10. And so I'll get minus 5y is equal to 10. And then I'll divide by minus 5 on both sides so I can isolate y. And I get y is equal to negative 2. So the y-intercept is not 0, 10. The y-intercept is actually 0, negative 2. So that does not work out. The x-intercept is 5, 0. So x-intercept is when y is equal to 0, what is your x? So let's try that out. So we have 2x minus 5. I'm replacing the y there with a 0. That's equal to 10. I get 2x is equal to 10. I divide by 2 on both sides to find what x is, and I get x is equal to 5. So my x-intercept is 5, 0. So that one here makes sense. So we have 5, 0. The y-intercept is 0, negative 2. Yep, that's what we found earlier. That works. So by disproving this one, we were able to show this one. The x-intercept is 2, 0. No, we already shown that it was 5, 0, so we can cross that out. The equation represents a non-linear relation. Not true, because we have first degree equations. There's no square roots. They're not multiplied by each other there. So this is not true. This is a linear relation. This equation represents direct variation. Well, let's take a look. To represent direct variation, you need to pass through the point 0, 0. And so when we go through 0, are we at 0 for our y? No, we're not. So this is not direct variation. It's partial or indirect variation. So really, we only have two that are correct here. And it's the x-intercept and the y-intercept of 5, 0 and 0, negative 2. So let's take a look if that's true. So 5, 0, 0, negative 2. Yep, we're good. Okay, so let's erase that and move on to the next question. This will probably have to be a two-part video because I'm running out of time in this one. So we'll post this in two parts for you to see. Let's scroll down and start the next question. We'll see if we can finish it before the video ends. Which of the following statements are correct about the table of value below? Select all that apply. So the x-intercept is negative 0, 2. So x-intercept means where does the line hit the x-axis, meaning when your y is 0. So when y is 0, negative 2, 0, that makes sense. Good. This represents a linear relation. Remember, linear relation, let's take a look. We have to do our differences to see if we're on the right track here. So minus 1, here we went up. So we have plus 1 here is a difference. Plus 1 here is a difference. Plus 1 here is a difference. So we're going up by consistent values for our x's. Here we're going up by 2. Our first differences are the same here. Plus 2 here as well. Plus 2 here as well. So since we went up by the same values every time, the difference between 8 and 6 is 2, 4 and 2 is 2, 2 and 0 is 2, then we have a linear relation. This represents partial variation or indirect variation. That's true because we'd have to go through 0, 0 for it to be direct. This is not going through 0, 0. It's going through 0, 4. So it is indirect variation. The slope is 2. Well, we can do our 2 divided by 1 here. So our difference in y over difference in x, and it is 2. The y-intercept occurs at 4, 0. That's not true. It would be at 0, 4. So you'd have 4 of these that are correct. Let's take a look.